All right, asymptotes. Okay, second to the last topic here. Asymptotes, they are invisible, lines on a graph. They're almost like a force field. It's where a graph cannot touch it does not cross this line. Okay, and there are two types of asymptotes that we encounter. We have vertical asymptotes, and we have horizontal asymptotes. That's all we have for right now. We'll get into later on other types of asymptotes, but for right now we just have vertical ones and we have horizontal ones. Okay? All right, so for instance, if I were to graph a function, f of x equals x over, and then we have x squared minus x minus 2. Okay? I plug that into my calculator. All right, that's from the last time. Let's clear this out, and we enter in. We have x. And then I've got x squared. Minus x minus 2. Okay, and we have this function right here, and I need to graph this function. So we go ahead, graph it. All right, and this is what I get. I'm going to change my window just a little bit. I'm going to go negative 7 to 7, just kind of zoom in that area right there to see what's going on. All right, you see these, all of a sudden these graphs, they kind of go way up and they go way down. Well, what we have right here is we have two vertical asymptotes. Vertical meaning up and down, and they cross the x-axis, all right? Now, if I were to do a little bit of algebra, I could see that if I factored my denominator, that it would factor to x minus 2, x plus 1. So the two values that make my denominator 0 are x equals negative 1 and x equals 2. And sure enough, right there at x equals negative 1 and x equals 2, these are equations of vertical lines. That's where we have the asymptotes. So in this case, my asymptotes are x equals negative 1 and x equals 2. All right, that's how you get them. Now, let's say that you just can't quite tell, or this is not something that you're able to factor, then how do you find these asymptotes? Well, you can always go to your table, and it's going to happen wherever you have errors. You have an error at negative 1, and you have an error at 2. Let's say, for instance, that it's not at like these integer numbers. You can always do something, okay? To find asymptotes, let's put this right here, at decimal numbers, okay? What we need to do is we need to change our table, all right? Right now the x values in the table are going up by integers. So number one, you need to change table settings. Okay? I'm going to go back and I'm going to show you. We're going to go back to here, okay? And I'm going to change this to a 7. All right? And now I'm going to graph it. I still get asymptotes, okay? And I still get 2 of them because there must be 2 places in the denominator where there's a 0, okay? But when I go to my table, I can't find, I don't see any error marks, so I can't tell exactly. If I go back to my graph, I can see that negative 1, negative 2, it looks like somewhere between negative 2 and negative 3, negative 2 and negative 3, that I've probably got an asymptote somewhere between there. I also, if I look over here, it looks as though I've got, also has an asymptote somewhere between 1, 2, 3, and 4. Okay, so somewhere in between these two x values, that's where I've got some asymptotes. So let's do this. Let's change our table settings. All right, and you do that by doing second table set. Okay, it's the window button. All right, right there. Where do we want to start our table? Well, we don't want to start our table at -5 when we know that it's somewhere between -2 and -3. So let's start it at -3, okay? This little triangle means change in the table. Right now, all the numbers are going up by 1. So we're going to have every number go up by 0.1, okay? And maybe then we would get a little bit more accurate idea. All right? Second table. There is -3. I'm going up by 0.1 every time. And somewhere between -2, -3, I'm not getting anything. But I want you to look at these numbers. What's happening to these numbers here? -0.5, -0.6, -0.7. These numbers are getting smaller and smaller. -1.1, -1.4, -2, -3.89. Oh, wow, -50. All of a sudden, my graph dropped way down at -2.2. At -2.1, look what happened. Now it's positive. So, what that means is somewhere on the graph between -2.2 and -2.1, there is an asymptote, okay? The curve, if we look right here, went all the way down, and then you see how as soon as we got to 2.1, we had a positive number, so it's going up like that. So the best we can do in this case, you see where the sign change was. You see in this table that the sign changed from negative to positive between -2.2 and -2.1. The best we can do is say that the asymptote is somewhere between those two without having to get a lot closer, okay? Now, the other type, all right, this is only if you can't find them at these certain numbers right here. The other type is horizontal asymptotes. Okay? All right, horizontal asymptotes. Let's go back to our graph. Okay? Horizontal asymptotes occur when x gets bigger and bigger way out there. Okay? So, vertical asymptotes are x equals functions because they're vertical lines. Horizontal asymptotes, they are y equal functions. Okay, so it's going to be a horizontal line and the equation is going to be y equal. To find horizontal asymptotes, what you will need to do is you'll need to go to your table. You want to go to your table settings, okay? Right now, I see that this one comes like this and this one comes like that. I want to know what line this graph is approaching, what y equals line. So when I go to my table set, okay, on table start, you set it equal to 1,000. This has to be a very large number, okay? You want it to be a very large number. So let's put 1,000 in there. I'm going to change this to 1, back to 1 again. We don't need to go by decimals, all right? So I'm going to go second table. And what is this number here? The bigger it gets, what is this? What is this 1e to the -3? 1e to the -3 is the same as 1 times 10 to the negative 3. It's scientific notation. And what it means is 0.001. It's a decimal point moved 3 times. And it's getting closer and closer. And the further we get, now you notice we've got negative 4. We're getting smaller and smaller and smaller. And then pretty soon, if we go far enough, this is going to go all the way down. This 9.7 is going to get closer and closer to 1. And then this will become negative 5. Eventually, it is going to 0. Y equals 0. Now, that's fine. That's when x gets very large. Go back to your table start. And this time, I want you to set it equal to a very small number, negative 1,000. Very small number. So negative 1,000. Okay? Second table. There it is again. The smaller I get, the closer those numbers, they are going to 0. Y equals 0. Now, here's the deal. If you enter in a very large number and a very small number, and you get the same place that they're approaching, this is your horizontal asymptote. Okay? Now, algebraically, you can't just say it's going that way, okay? They use a little bit of notation, and this is what they do. They use this right here. They use the word lim, which is short for limit. And what they say is that as x goes to infinity, and all that means is as if we start this table and we go very, very big numbers, that's what that means, then the function equals 0. And what that means is that the function goes to 0, or just because this case is 0, it doesn't always. We're going to say it goes to a, and a is just some number, okay? And now, if you take the limit again, and x goes to negative infinity, which means x gets really, really small, just like we did here, and the function approaches the same number, and these two numbers are the same, okay, then y equals that number is the horizontal asymptote. Okay? All righty.